Hello? 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 I think I'm live. I think I have audio.
It says you're live.
I hope I have audio.
Oh, I got an ad. Give me a sec. I don't have YouTube Red.
I got an L in the background seeing if this is working.
Please invest in great photography.
12-second unskippable ad, Paul.
12-second unskippable ad.
Your customers have one person.
Alright.
Audio okay. Awesome.
Okay, we're good.
Awesome. Yeah, something was wrong with OBS settings, so... Yeah, hi! I'm not too great with OBS. I don't use it often enough. So that was just a challenge for me to figure out why I had no audio going out. Okay, let's see. Let me move this window around. Okay. Okay, I think I'm set. Hi. So today I have a MacBook Pro, 16-inch, the A2141 model, and in my opinion, this is one of the worst models that Apple has ever created. The absolute top of the list is the MacBook, the little 12-inch Retina. That thing was horrendous. Absolutely terrible. This thing is getting pretty close. It's either right up there or above it, because this thing costs twice, probably 3 times more than that MacBook did. And okay, fine, the MacBook, the 11-inch or 12-inch Retina, it was junk. It was a failed thing to begin with. The processors were just not right. It was terrible. This thing, and it was cheap. That's the thing. It was cheap. This thing is expensive. Let me show you overhead. This is what we're working on here. So this thing is very expensive, and what you're paying for, it should not have flaws like it does. This is just absolutely ridiculous what this machine is. So first part of this video is basically going to be a tutorial on how to open one of these machines. So here I just have the back screws out, and I'm just going to go through the process of opening it and getting the logic board out, because it seems that a lot of people that are trying to work on these things have no idea how to open this. And it's infuriating when you get a machine from another shop and things are destroyed by a technician. So first part is for any of you technicians out there, any of you home gamers, anybody that wants to open an A2141, this is how you do it. First, remove the pentalobe 4 screws. I didn't bring a pentalobe 4 because I already took them out. They're right here. So remove the pentalobe 4 screws, and now this plate doesn't just come off the back like the old machines did. There are fingers that are slid in back over here, and they are hooked underneath the fan vents. So you can't just lift this up. You will destroy the fan vents, you will destroy the back, which I see already somebody did here. There's a little bit of a crease right here. Do not just try to lift this thing up. From back here anyway. Up here, there's a couple clips. There's 2 very strong clips here and 2 weaker clips right here inside of it. So first thing we're going to do is just pull, so you can get your fingernail. If you don't have fingernails, sometimes people use suction cups to pull on this. Some of the machines don't have this vent here that you can get your fingernail underneath and start lifting up on this. So I get my fingernail underneath here, I could lift up on it a little bit, and then I could get a couple fingernails underneath the end here. So I got my fingernails all underneath here, now I could lift up on it. Click. That's that one. This one came out, this one came out, because they're really light. The middle ones, they click in really light, and then we have the other one on this side. Click. Now we got to push the bottom cover that way. So I get my fingers up over here, my fingers are down here on the bottom piece, and then I'll grip the bottom. My fingers are on the top. I'm pushing with my fingers, I'm pushing back on the computer and pulling forward on the bottom case. So pull, The first couple times you do that, you're going to lose some skin on your knuckles until you figure out where to keep your fingers. And there we go. We got the bottom case off. So you see the fingers here, these things, all of these are locked in here so that you can't lift it straight up. You have to pull it off first. So now we have the logic board. So this is no power. The customer said just one day it just stopped working. There was no specific instance. There was no drop, or there was no liquid spillage or anything like that. It just stopped working. So first thing I notice is that, well, we saw on the back cover, somebody has had this open before because this was bent a little bit. The the battery cover, little sticker that goes over this just to protect this, is gone. And a lot of people don't like putting that back. I don't know why. It's not that difficult to just put things back. But first thing we're going to do is disconnect the battery. So I'm going to unlock the little battery lock. Let me show this. This is another thing that happens a lot. People are breaking these connectors in droves, and we're running out of connectors to replace. Ooh, why are you locked? Show this under the microscope. Okay, so this is a standard connector on most MacBooks. So the keyboard connector looks like this, the speaker connectors look like this, the microphone connector looks like this. Well, some speaker connectors, not on this board. A lot of the connectors look like this. So it's a little wire, the flat wire here, that is inserted into this little connector. So the first thing we need to do, be careful with metal tools around this, because there are live voltages on here. There's voltage and ground across this. You don't want to connect any of these. So you don't want to stick a pair of tweezers underneath this lock, because all of these pins are live. So I'll take my fingernail, I'll flip that up. Let me do that with a piece of plastic so you can actually see how it flips up. So I'll come in here with a piece of plastic and just flip that lock up. See, and now if I did that with tweezers, my plastic just hit these two pins, and it just shorted these two pins out. And you can see that they go to two different spots. So there's two different voltages on there. If I hit that with my tweezers like I did with this plastic, I may have damaged something. I may have burnt something out. But I did it with plastic, or I do it with my fingernail, there's no damage there. And then we're going to pull the wire straight out of it. There you go. That's how you disconnect one of these connectors. Don't try to pull up on the wire. Don't try to pull up from where the wire is on the whole connector. Don't rip the connector off the board. Just turn the little lock up and pull the wire out. So that's the battery connector. We have the battery out. So now I'm going to check for voltage. I take my amp meter here, take my USB-C power, and we're going to plug it into the machine and see what we get. Okay, we're at 5 volts. It went to 20 volts. So we do have some kind of power going on here. We have 90 milliamps. So the machine's not starting. It's not turning on. So this tells me that the charging system, the CDs, the CD3215s, the CD3217s, I forget which one's in this. CD3215s are in this machine. They should be fine, because we negotiated 20 volts. Now we're at 90 milliamps at 20 volts. Let's take a look at what our PP bus voltage is. That'll be telling onto what's going on here. So I'll put my ground probe on ground, my black probe on ground, that on PP bus, and we have 12.6. So PP bus, 12.3. Okay, the machine's turning on and off. So the machine's turning on and off. It's the T2, which is doing what the SMC used to do, is telling the ISL to first make 12.6, and then the whole thing turns off, and then the ISL just goes to its base voltage of 12.2. 12.3 for this one. So that's the base voltage that the ISL is going to create. And then when the T2 turns on and communicates with it, it tells it to adjust itself to 12.6. So we know the T2 is kind of working, the charging system's kind of working, because we get the proper voltages there. So from experience, I'm going to go after it. So first off, when you have it turning on and off like that, that means you have some kind of short down the line. Some other power rail farther down the power rail sequence is going to be shorted. So from personal experience with these machines, I'm going to immediately go after the SSD power right here. So just going to skip most testing here, and I'm just going to check for a short on SSD power. 1.7 ohms. 1.7 ohms is a short. So our SSD is shorted to ground. Now, I don't have any liquid damage in the area. From here, the chip that creates the 2.5 volts looks to be in good condition. So this area here, this looks to be in okay condition. The chip is in good condition, so I have hopes that this might actually work. So this right here, this whole area is why I call this machine one of the worst that Apple has ever produced. Because this is a high dollar, high value machine. People expect this to be their flagship machine. It's one of the most expensive ones they make. It's the biggest one they've made in a long time. This chip right here is a problem. This right here on this is PP bus. On this capacitor is PP bus. Right here on this coil, that's 2.5 volts. It gets, like, if you think this is close, like, this is my tweezers. My tweezers are almost needle points. I don't have something really to show size relationship. My finger? This is my pointer finger? That's how big we're talking about here? So this is how close the 12 volts and the 2.5 volts is, but underneath the chip, it gets even closer. You have a fraction of a millimeter between the 12 volts and the 2.5 volts balls. If anything gets underneath this chip, it starts sending close to the 12 volts to the 2.5 volt rail and burns out the SSD. Never trust your data on a 16-inch MacBook Pro. Never trust your data on the 16-inch MacBook Pro. Always keep a backup. Never trust that your data is secure on the MacBook Pro 16-inch. It will let you down. It will destroy your data. Keep a backup. So we already know that this is shorted. So this side looks fine. Let's take a look at the other side. So now we're going to take the board out of the machine. First, I'm going to start. I have my my Wow Stick 1F here. I have my T3 tip on here. And we're just going to start taking out all the T3 screws first. T3 screws are for mostly the connector caps. It allows you to disconnect the connectors all around and everything. So that's what I'm going to start with. So first is the hinge cover here. And we have the touch bar. I believe this is the touch bar touch connector, and then this is the touch bar image connector, or vice versa. We have one USB-C port. I'll take the cover away from it too. And now these connectors, you just get a fingernail underneath one end of it and just pop them straight up. That's how they come off. We have another one of the locking ones, like what I just showed you. Now here I have no power to the board. The board is disconnected. The battery's not connected. So now I'm a little safer using tweezers around things if I need to. But I unlock it, pull that out. So I'd like to just work from one side of the board to the other. So I'm just going to work my way across the board, doing all the T3 screws, taking out all the T3 screws, and then I'll come back, take out all the T5s, then I'll come back and take out all the T8s. So this is, there's two board screws that are T3. So that's one of them. Now we have the screen cable guide. Those are really long screws in the screen cable guide. Then the screen cable connector. Now, screen cable just pops straight up too. The Wi-Fi, I'll come back here. We'll do the Wi-Fi. The Wi-Fi, these are little coax connectors. They're little round pieces with a pin up the center of it. We just, right underneath where you could go, they're very easy to open up. So you could go underneath the wire or right underneath the metal part of it. You just push straight up and they pop right off. They're very light to come off. These wires are pretty sturdy, so just straight up on it. There you go, they come off. We have the trackpad and keyboard connector underneath this one. These just straight up. Okay, let's go back to over here. I forgot this one in the corner. This is the speaker connector on this. These are common among a bunch of other things. They're speaker connectors, they're fan connectors on some older MacBooks. They're pretty much all the same here. And this is another one that people have problems with. So here's, not there, there's the connector. It's rather big, kind of hard to fit on. Well, there's the connector. And you can see, when you see it enlarged like this, with like, if I hold a Q-tip next to it, you see how big this thing is. It's no bigger than a Q-tip end. So it's kind of hard to see what you're looking at when you don't have it magnified like this. But we can see that there's a definite separation between the connector and the socket. So this is the connector with the wires in it, and this is the socket that's on the board. People like to come underneath this thing and just rip this whole thing off the board. And it's kind of against what you're taught when you're working with electronics and what you think of. With this one, you just go underneath the wire and lift up the wire, and it comes right out. So it's really weird. You don't usually want to lift up on wires on any of this stuff, but this is the one that you do want to lift up on wires. You don't want to get underneath this connector, get something underneath this connector and rip this connector off the board. Because most of the time it takes the pads with it, and we have to run wires, and it just turns into a total mess. Unplug that one. Okay, where was I up to? Right here. This is the other T3 board screw. Now the T3 screws as well, they kind of look the same. So the board screws are really long and they have a little bit wider head. So you have to kind of keep these straight. If you don't know where they go, you can damage something, because this is the same thread as the ones that go in here to hold down the connectors here. If I put this screw in this hole and I keep screwing it down, I'm like, the connector's not tight, so I screw it down more. The cap is still not tight. I keep screwing it down. I will put this screw right through this board, and that will completely ruin this board. This board is garbage at that point. So you have to make sure you put these screws back where they belong. I just put them all on one magnet because I've taken enough of these apart that I know where these go. If you don't know where they go, lay them out. Do something to identify which ones are which. These two are the longest. These two in this cap are the next longest. Then these are the same. They're kind of short. And then the silver ones that hold down these, they are the tiniest ones. These silver ones here, they are really tiny. I'll take the hinge cover off because it's kind of in the way of this one screw. So I don't want to take off that screw before taking off the hinge cover. Now these will have to be a little bit longer. At least this one has to be a little bit longer because its screw hole is actually another screw. So when we take this connector off, you see the screw hole that I screwed into is just another screw. And these are a little bit longer for both of them. So this standoff here is a little bit taller than the other ones to accommodate for a little bit longer screw. If you put this one in these, it will work. You're not going to damage anything. But if you put this black one into one of these, it will destroy the board here. Okay, that's all the T3s. So now we're going to switch over to T5. T5 are mostly the structural screws that hold the board in the case. They're all the same except for this one. This one is a little bit longer. I don't know why they put the little bit longer one out here on the edge instead of in here holding the like common sense almost dictates that you would put it here holding the Wi-Fi antennas down, but that's not where it goes. It goes over here. Some structural engineer engineered a longer screw in this corner for a reason. I'm not going to argue with it. They actually made the effort to get a different screw for that, so that's where the long one goes there. This is the battery screw. It's a big old head screw. That's what holds the battery connector. You don't have to take this off to turn off the battery. As soon as you disconnect this wire, there's MOSFETs on the battery control board that completely disconnect the battery from the board. So as soon as this little wire is disconnected, the battery's no longer in the system. If it is in the system, we have had batteries come through here that once you disconnect this, it's still connected. There's still power on the board. That is a bad battery. You need to get rid of that. That's a safety hazard. That you have to be careful with batteries and people's machines. So if you ever find a battery that does that, get it out of there. I don't care if it seems like it's good, it seems like it's working. If you disconnect this wire and that battery stays live, you throw that battery away. Now we switch to the T8. There's only 2 T8s at the ends of the heatsink. This one has the screw hole down the center of it for that connector cap. Okay, now round up the rest of the connectors. This one, it's the headphone port. This is the power button. Be careful with the power button one. On all of these machines, the power button one is tiny and easily broken. And if you break the power button, it's nearly impossible to fix that power button. And you can change it, but then the person will never have Touch ID again. They'll never have a fingerprint sensor work again. Okay, now we're ready to take the board out. Just going to get my fingernail underneath the corner. And I like to shake the board a little bit as I'm going, and it reveals where the board is pivoting, reveals where things might be stuck, or I may have forgotten a connector. These gaskets are glued down a little bit. And there you go, we have the board. So first thing, I do want to point out something here. So this is the inside of the case. And this is the airflow of this. It all comes in through these corners here. So the fans are blowing. They're exhausting air out of here, which is coming out of the bottom, and I think just out of the bottom. I don't think it goes up to your screen anymore like the old ones did. So you have all the air coming out of the bottom. So any air that's going out of the case has to be made up somewhere else. So these vents here all along the side is where fresh air comes into the machine. And you can see how dust likes to build up on both sides here. There's just dust all along here. So this is where the air intake is. So all fresh air from the outside, any desk that you put this down on, any fabric that you put this down on, it is basically vacuuming it off. Because this is the very bottom of the machine. This is what's on a desk. So the vents are right here. So it's vacuuming off your desk and pulling all of that into itself. So that's where all this dust always comes from. So now we take a look at the logic board. We already saw the top. Top's nice and clean. This is the area of concern here. We go to the bottom. The bottom does not look good. Like here, we got a lot of dust piled up on things. Here, you can probably even see from the overhead cam, we got some bright green corrosion right here. Got a lot of dust tracking and everything. Just like all of these test points should be bright. You got a spot there, a spot here that's gotten dull. Take a look at the other side. Just dust. This coil's starting to rust. You got a pile of dust up against this little standoff here. Got some corrosion going on here too. But this is what we're looking at. So this is PP bus. The one that's more corroded, that's PP bus. We don't have a problem with PP bus. PP bus is fine. So that's weird. But these four here, this is the 2.5 volts. I can see just from looking at it without a magnifying glass or microscope that looks like it's destroyed. That last one in the corner there looks like it's destroyed. So let's get that under the microscope. So you can see around it that there's no, it doesn't look like there's a liquid spill here. There's no tracing of liquid. There's no lines. There's no nothing that liquid was spilled in here. But this is just, so piles of dust will collect moisture. So if you have a pile of dust on something and then you go into a moist environment, you put your laptop on the bathroom counter as you take a shower to listen to music, all that moisture that's in the air is going to get sucked in by the little piles of dust that are on things, and they're just going to get wet. And then you have stuff like this grow on individual components. So yeah, this one's definitely exploded. You can see that this one's charred and exploded. All the rest don't look that great. So we'll wind up replacing all of these. And then this one here, too. It's got a garden growing on top of it. So this has a decent chance of survival since the 2v5 cap is what blew up here. Even if it was the PP bus cap, this has a good chance of survival, just because the ELC 180, this chip right here, this chip is in okay condition. So as long as this chip is in okay condition, as long as Ocarina is in okay condition, this side of the board is very important. So as long as these are in okay condition, this is probably going to be okay. So first thing I want to do, let's get this guy off of here. Yeah, that's not even going back on there. That burnt up the board a little bit underneath it. And then this guy's got to go. He's breaking apart into pieces. Okay, I need to take all these off, so I'm going to take them off with hot air. Some fume extraction. There'll be some noise. We'll get a little bit of flux on this. And then I'm also going to turn the board around. So I'm right-handed. I hold the hot air in my right hand, and I don't want to blow the hot air towards the NAND chips. Underneath this black thing here, this is the SSD. This is the NAND chips underneath here. So I don't want to blow the air towards the NAND chips. I want to blow the air off the edge of the board. Hey JP, how's it going? First time I looked over at chat, since I'm waiting for the hot air to heat up. So you can see the corrosion boiling up with the flux and the hot air. So we're just going to get rid of all of these. I'm going to replace all of them. Does this resistor need to be replaced? We'll try to touch up the resistor and see if that can stay. Okay, let's get a Q-tip in there and clean some stuff up. Yeah, that resistor's got to come out of there too. That's not good. Yeah, I'm surprised. I think that this PP bus cap that I took off of here, I think it was shorted, but it must have shorted in a way that it exploded, or took the pad off or something. Because look at that, there's some corrosion around there, there's some burnt board around those two vias and everything. So that's interesting, that didn't cause the failure. see if we can get this resistor off without hot air. Anytime I can get away with not using hot air near the SSD, do that. Okay, resistor's off. We will replace that. Let's clean up these pads, add some new solder to them all. That looks good. See if I can get this. This is ground, so this probably will not work with a micro pencil. Nah, the micro pencil won't heat that up enough. Let's get the full-size iron in here. There you go. And I'm not going to replace this capacitor. PP Bus has enough capacitors in the area. It doesn't really need this one. But I do want to clean all of this up. I don't want any chance of it shorting out or anything happening to it again. Okay, I forgot to bring the donor boards over here, so let me leave you guys with a cat as I go get my donor boards. Be right back. Aw, I see the cat walked away. That is Blackberry. That is my little sweetheart. I love this cat. I'm going to miss this cat so much when Lewis takes her away to Texas. Nope. Yep. Okay, now I need to find a donor board. Did I grab the right pile? I did not grab the right pile. Wait. Oh, that's great. I'm not working on a 2141. This is a 1990. Fail. That would be a problem. So yes, this is a 1990. I'm gonna have to go back and edit out all the 2141 references. Because yes, the 1990 is absolutely awful because of this issue. Be right back. Okay, so I retract some of my statements. This is a 1990 15-inch MacBook Pro. And yeah, I'm going to have to go through multiple donor boards because this is a common area, and all of this always goes bad. What sucks about it is that a lot of the donor boards are donor boards because of this, so it's hard to find donor boards that have good caps. So I have 3 on here. We'll start with those 3. These caps are weird that they're not completely square. They're actually taller than they are wide. So you kind of got to put them the way that they sit. It's amazing that the pick and place machines in the factory can handle that. Let me find one more on another donor board. Okay, I got one more. Then with this, I'll also add a little bit more flux. And you'll see when I put this last one in with that flux, everything else will melt and you'll see them all straighten themselves out. So you don't have to worry about getting everything straight as you place them. So when I place this last one, everything will remelt and they'll all straighten themselves out. And the resistor. Okay, that looks good. But the edges of here don't look good. Everything's got just this sheen of dust on it. It just doesn't look good. Top side is fine. I guess most of the air flows under the bottom of it. And then this side, the other side too. Look at all this. It doesn't look like there's much damage. It's on the road to damage. So what I'm going to do is go dunk both of these edges into the ultrasonic cleaner. So we'll get both edges all nice and cleaned up. We don't need to clean the entire board because there is no liquid damage here. The rest of the board looks fine. It's just the edges of this one and the 2141, the 1990 and 2141. They have these issues like crazy just on these wing edges. So I'll go ultrasonic this and come back and you can see the results. Can you see the little BlackBerry? Mr. Clinton came in to say hi. Hey. How you doing? Come here. What? What? Say hi to your audience. What is this? We have a gallon of lemonade.
You want a bucket of weenies?
And a bucket of hot dog pretzels. Cool. I didn't have lunch yet. Awesome. Is there a name on it? Thank you, JP.
Hey, girl.
That's freaking cool. Down the whole thing.
You got a straw?
When you get a donor board with a specific issue, dead CPU, dead NAND, do you mark it as such? Seems like it would save the technician time. Sometimes. A lot of times, not specific like notes or something like that, but like clues. Like if I know it's a dead CPU, I'll put an X on the CPU, put an X right on the heatsink or something like that. You leave clues for your future self. Don't ever be mean to your future self. Always leave clues to your future self. Here I'm just drying the board out the rest of the way. The ultrasonic was not up to temperature yet, so it did not take off all the flux. And we have to dip again. Just get a Q-tip on that. Okay, that looks a lot nicer. So now if you have one of these boards, preventative measures can be taken to prevent this from happening. I've taken these boards and covered these capacitors in hot glue or conformal coating, whatever you got. That'll seal them up. That's the first thing you want to do when you're doing that is to heat the area, preheat all of it so that there's no moisture. You don't want to seal any moisture underneath anything. It's just ultrasonic residue around this. So it did take off the flux. And then the other side where all that green was all over the place. Take a look at that. So we still got some green on things. I think we're going to do a little bit of reflow in this area. Yeah, there's a lot of things that are just too dark. You don't want to see solder looking like it does there. That's not good. So we'll just hit this with some flux. Hit it with the soldering iron. I'm just going to put flux all over everything first to mark the areas I got to work on. These two. I'll probably reflow the CD as well while I'm working over here. This. Yeah. So now we'll just take our micro pencil with some fresh solder and we'll just hit everything. If anything comes off the board, it shouldn't have been on the board to begin with. We'll put a new one on. Brighten up all those connections. Looks good. Touch the big one a little bit. That looks nice. Just want everything to be a nice bright connection. This one here won't brighten up. We're probably going to have to replace it. Yep, came off the board. Doesn't belong there if it came off the board. And now we need to get the soldering point to brighten up. Need to get its pad to brighten up. If we can keep that in focus. There you go. Scrape away the corrosion a little bit. This guy's probably going to go too. Yeah, he's not brightening up either. We're just going to lift him off the board. So now we need to get some new solder on those pads. Nice little puffy pillows. There you go. Now we have some stuff over here. Oh, he came off the board. Let's replace him. That brightened up, even though it moved. Went right back into place. Okay, everything brightened up there. That was the end of it. Let's reflow the CD, and then we'll get into changing the other things. Get a donor board. These okay? Those are good. Just really dusty. Let me clean off my donor board before I try to take them off. Okay. The CD's already flooded with flux, so I don't need to add any more flux to it. I'm just going to slowly heat up around it. And watch those solder balls. I don't like them floating around there. Okay, it's dancing, and I'm done. So that's a good reflow. Now let's change these couple of things that we took off the board. Start with the inside, that resistor. Hey, what are you moving for? Pick up some flux somewhere else on the board. Just playing in the area. There we go. It's all nice and clean. Okay, that looks good. Should have known better than to use U-Break iFix. Left a nice fingerprint on the backside of my camera lens. That sucks. Because that is not easy to open and close. That is not easy to correct. U-Break iFix is very subjective. They have so many stores, they have so many people working for them. Some of them are going to be damn good at their job, and others are not going to be so hot. There's a couple U-Break iFix that send us MacBooks for us to repair for them. And they're pretty good. They don't mess with things that they don't think that they can fix, and they just send it to us. I respect that. There are a bunch of other shops out there that think that they can fix it, and then when, oh my god, I don't know what the hell's going on, they send it here, and it's unbelievable the quality, what they've done to the person's machine. Every time I see it, I want to make a video and just call them out on it, but that would be unprofessional. But people need to know that some of these shops are doing this to their machines. Customers are right to know what you did to their machine. Stripping out all the screws, drilling out things all over the place. These boards are very delicate. They're not meant to be handled by people. Just your fingernail can easily flick something off on here. Just trying to pick it up, and your fingernail goes the wrong way, and this will just break right off. And you'll be lucky if it just breaks right off, and that's the end of it. But most of the time, it'll take the trace with it, or you'll break half of it, and it'll be shorted to something. And then you got to go and search the entire board to figure out what you hit. Now, these boards are not meant to be touched by human hands. You got to be real careful with them. Okay, that looks good. We'll dunk this edge in the ultrasonic cleaner one more time. Probably this corner again. And then we can power it up and see how it goes. So, one moment please. I am back. So the board, just the edges were dunked in the ultrasonic cleaner, and then dunked in some dirty alcohol, which we dunk all the boards into, and then sprayed off with a spray bottle full of clean alcohol. So the alcohol displaces all the water from the ultrasonic cleaner, allows it to dry faster and with no residue. What I like to do after that is I tap it on my mat lightly, and if there's any liquid left under anything, if I didn't heat something up enough, if there's liquid under the CD, you'll see it shoot out from underneath it when you tap it like that. So, no liquid came out of anything, so this should be nice and dry. Let it cool off a little bit. We'll bring the case back over. Let me find a brush. We'll brush out some of this dust in here. Okay, some of that's tougher than a paintbrush will allow. Use a Q-tip with some alcohol. So we should test before we put this in here. So I have my multimeter in ohms mode, resistance mode. Black on ground. We'll test the 2V5. 10,000 ohms. So that seems good. So let's see what it does when we power it up. So inserting these, I start from one side and work my way along it because you have to get all the connectors out from underneath the board. This one's not really difficult. There's other ones that have connectors here and connectors here and connector here and a connector here and a connector here. That gets really difficult. This one's not that bad. So I don't need microphone to test it. I do want a speaker to know if it chimes. I'm not going to plug in the battery yet. Plug in the power button. I don't need the audio jack, but I just plugged it in anyway. Okay, first, let's see what power we're getting. Okay, we got something then nothing. We have nothing now. Okay, there may have been more wrong around that CD than what I was thinking. I hear a BlackBerry. Yeah, there was more going on around that CD than I was thinking. So we're going to have to do some more work on that. BlackBerry? Hi. He's over in the corner meowing at me. Okay, so we didn't have a short on 2V5 anymore. Why am I showing 84 ohms? Oh, I might have power on it. Let's see. If the capacitors are holding power, it messes with your... Nope. It messes with your resistance readings. And 90 ohms, that's not right. How about PP bus? Oh, that's right. 7 mega ohms. So did something else go bad over here? This is weird. Let's see. Check that one more time. 150 ohms is going back up. That's strange. Definitely nothing wrong with PP bus. Nope. Let me get a test charge port. Okay. Now we have a test charge port. We could power it up on the bench. Does the same thing. Power then nothing. Do I have power on anything? Did it give me anything or any capacitors charged? Okay, I got 2 volts hanging out on PP bus. Nothing on 2V5. But 2V5 is now short again. This is weird. Want to check condition of the NANds. Everything around there looks good. Everything's clean in here. The only area for power that we were messing with is this. I'm going to take the CD off. Okay, it doesn't look bad, but you know what may have happened? So, I don't know if any of you were watching, I had 2 solder balls that were floating around up here. One of them I picked up, the other one was a tiny one. It was about the size of this one that just formed over here. And I just let it go, because it ran away from me. I'm like, it's small enough, it shouldn't affect anything. I think it did affect something. Because you see, when I took the CD off, I pulled it up pretty straight. I'm pretty good at taking the CDs off, the CD3215s off, to where if there's nothing wrong underneath it, I could just put it right back down on the board. But this ball right here, you see that it's a big one, and this one is tiny. So that is telling me that those two balls, where is it on this? Right there. Those two balls were combined. That solder ball went underneath there and combined those two balls. And when I lifted it up, the combined ball just stayed on the one pad. Because that's why all the solder came off of the one pad, and it all, for both things, this way though, it's this pad, because we're upside down. So both balls worth of solder went to one pad only. So this CD is probably fine, and that those two balls were combined. So I'm gonna go get a new CD, and we'll replace this CD, and this should probably be fine. So I just visited our sponsor, store.rossmangroup.com, and picked up a brand new CD3215. So we got a brand new one here, complete with solder balls, so we won't have to reball anything. Now what we do need to do is prepare the pads. So I'm going to be doing a bunch of soldering and turning the fume extractor back on. Okay, a little bit of flux. Take our soldering iron with new solder. Fresh blob of solder on there. Just clean up all of that remainder of the solder balls. And then we'll take the wick, which can also be found at store.rossmangroup.com. And we'll clean all of these to flat. Okay, everything's nice and clean. I have a blackberry in the back of the room meowing at me. What's up? Aw, she looks so cute. Blackberry? Blackberry? What's up? Love that cat. Okay, it's nice and flat. We have new flux. We have new chip. Make sure we put chip in the right orientation. So this one you don't have to look up the orientation because you have one missing ball out over there. So you just line it up. That's where pin 1 is. That's where the little circle is on the chip. Okay, at first when I start heating it, I'm just going to hold it down until most of the flux that I have there moves away. Once it starts boiling, then I don't hold it down anymore, because then it's going to get close to melting, and if you're holding it down while it melts, you're just going to squish all the balls out from underneath it. So I saw it move into place. I can make it dance a little bit. There you go. Let it cool off to where nothing will move. And we can pick it up and rapid cool it. Just put in the fume extractor. Once it's cool enough to touch, I should be able to turn it on. Five volts, 250 milliamps, 20 volts, 40 milliamps. Okay, we still don't have power coming on. Let's check some voltages. PP bus is 12.6, that's fine. How about the 2V5? 2V5 is 2.5 volts. So now what this is indicating to me, so the machine is on but not on. So we have our voltage restored to the SSD. PP bus is still fine. That little mess over there, we fixed that. So now we're not turning on. So I bet from experience, the next thing that's going to be going on is that this is going to be in recovery mode. Or it needs to be DFU revived, because it had a problem with the SSD. The T2 chip could not contact the SSD anymore, so now it's gone into a limp mode or something like that. It's gone to a safety mode. So now we need to get this back into its case, so I have to clean it one more time to get all this flux off of here. We have to get it back into its case, and then I have to hook it up to another machine with Apple Configurator, and we have to run the DFU revive on it. So I will go clean this up, and I will be right back again. This is one of Blackberry's favorite little spots to sit. She's in the shelf. She likes sitting in the shelf. What are you doing, little sweetheart? What are you doing? You're so meowy today. We have an Oreo on the scene now. The wild Oreo spiting in his natural environment. It's the wild Oreo hunts for food and head pats. Okay, cleaned again. And we'll dry again. Oh, damn it, I should have grabbed my DFU machine. I will have to leave again. Okay. That should be good and dry. Let me go get my DFU machine while that cools. Be right back. Okay. Now, of course, this is getting complex. Okay. For DFU, for running a DFU or a recovery or revive or anything like that, you need to have most of the accessories plugged in. You need to have the trackpad and keyboard plugged in. You need to have the touch bar plugged in, I believe. You may or may not have to have the battery connected. Sometimes it works, sometimes it does not. But let's see if this is in recovery. So this is my laptop. Let me make sure I don't have any personal information on the screen. Oh look, updates are available. I don't know if anybody's been watching the news that they identified a bunch of security risks in macOS, Catalina, Big Sur, and Monterey. And they pushed an update, looks like 2 days ago. Just hit the news yesterday. Okay. No personal information on the screen. Let me see if I could set this up to actually show you what I'm doing. Trying to move this over. So I have a host computer here with Apple Configurator 2 on it that you can get from the Apple App Store. So now I'm going to take a regular USB charge cord, plug it into any port on my machine, and then I need to plug it into the right side or left side closest to the trackpad port. So first I'm going to power up the board, and then I'm going to plug in mine. Now this should say recovery. It should say maybe DFU. Yep, it's in recovery mode. Okay, so I don't have success running the DFU revive. That shouldn't have come up. Since we're in recovery, this should not have come up unless it restarted or something. But I don't have I don't have that much success running a revive from recovery. So what I'm going to do is I'm going to put this into DFU mode. I'm going to force it into DFU mode, and then we're going to run DFU on it instead. So what I'm going to do... Oh, you can see it on the screen. Okay, so I can leave my laptop up here. So these jumpers here, this is the power button. This is for testing purposes. They actually had a little tactile button on here for testing the machine. But this is for power, and these two up and down here, these are for to force the system into DFU. So what I'm going to do is get power ready to plug in, and I'm going to short these two together. So this is shorting 1V8 to SOC force DFU. So I'm going to hold that down, plug it in. I'm going to continue to hold it for a second. I don't have an amp meter to tell if it went in, so I'm going to just keep holding it until I get my machine plugged in. I'm plugging my machine in now. And this should say DFU on the screen instead of recovery. It still says recovery. Okay. I didn't get the pads well enough. Let's do that again. Plug it in. See that connect accessory or cannot use Thunderbolt accessory? That should not come up. And it won't force into DFU. That's not a good sign. So now I want to check and see if the 1V8 is here on this board. 1V8 is present. So I am shorting 1V8 to DFU, force DFU. Well, it's not necessary to put it in DFU. We'll try doing the advanced, we'll try doing the revive. Always revive unless you get permission from the customer to delete their data. Doing anything other than revive will erase the customer's data. So that's not a good sign that it's stalled. It's installed on installing. That means it's having trouble writing. So we might still have a problem with... Oh no, wait, we got fan spin. So it is writing. It is putting itself in the proper mode. Okay, it just took longer than it should have for that. So if this worked, what we're going to see come up on here is a smaller box than the recovery, and it's just going to have a lock symbol in it. That means the T2 is locked. it's in the normal operating mode. So right now, if I open up his machine, which I cannot due to space restrictions, I should have an Apple logo on his screen. It should be updating things. Let's see. Yes, I have an Apple logo and a loading bar on his screen. So what I want to see is that lock symbol come up here. This reviving device should go away, and I should get a lock symbol here, and then I know everything went fine. The SSD is still good, T2 is fine, all the communication from the CD3215s is fine. So this is the current state of repair for most of these newer machines. It's like right to repair. When they talk about people that are against right to repair, the one of the biggest ones that comes up in the conversation is John Deere, and how you can have a tractor that a fuse blew. Say a branch got caught in a motor for something, and the motor overran its supply and burnt out a fuse. So now I can go, I know what I'm doing with a tractor, I can go in, find the fuse, replace the fuse, but that motor will refuse to turn back on until you hook it up to a software system and tell it that, hey, you're okay. That's exactly what's going on here. That the SSD was no longer had power, so the T2 chip could not communicate with the SSD, so now it locked itself out in this recovery mode where you can't do anything with the machine until you hook it up to another machine and tell it, look, you're okay. Check all your systems, you're fine. You can turn back on. And for now we have access to this Apple configurator. There's rumors going around that Apple's going to remove Apple Configurator from us, and then that's going to make repairing this stuff impossible, unless somebody has a hack around it. So there we go. We got our lock symbol on the screen. So that means this is good. So the T2 is communicating properly. It's in its normal operating mode. So this machine's fixed. Hey, we just got a chime from it, too. Hey, Lewis is in chat. No, Lewis, I messed up on the title and the beginning of the stream. This is a 1990, not a 2141. But yeah, same problem. It should be a shorted SSD, but we had just a cap on the other side. So we had to go through the whole thing of identifying the cap, changing the cap, and now we have a working machine. And do I have customer data on the screen? Can I show you anything? I can show you that it's on. There's the clouds of what is this, Catalina OS. So it's on, it's in their OS. Customer name's on the screen, I can't show you the whole screen. So there you go. We got a working machine. Move some stuff out of the way. So we have this is an MacBook Pro, model number 1990, A1990. It's the 15-inch MacBook Pro from is it a year ago, 2 years ago, maybe 3 years ago now? This is 2019, I think. We had a short on the SSD line, found the shorted capacitor. We changed the whole bank of capacitors because they all didn't look good. Found some corrosion on the other side. We messed up a CD in the process, so we changed the CD3215 out. Now we have we had a machine that was in recovery after that, so We went through the recovery procedure of reviving the device. So we revived the device, so the customer data is still here. There's an additional level to that where you can restore a device. And restoring a device will wipe the SSD, wipe the OS off of it and everything, and you have to then download a new OS and start from scratch on it. So you lose all customer data, and it's unrecoverable. There's no way to get anything back after you do that. So sometimes you have to go that far if there's something corrupted in the OS and it won't let the whole machine start because of it. That's something you can try, but you do lose all data. So make sure you either can get a backup or it's your last-ditch resort is to do a restore. But the revive works most of the time when you have something like this, and there you go, we're up and running. Hope you learned something. Scroll through chat a little bit, see if you got any questions that I didn't answer. So yes, anybody, the beginning of this video was dedicated towards a tutorial on how to open one of these machines. So if you're going to open one of these machines, you're going to take out the logic board. I encourage you to watch this video from the beginning and take a look on how you're supposed to actually open this and disconnect connectors and stuff like that. So it is lunchtime for me. Thank you for the hot dogs, JP. Definitely having a couple more of them for lunch. Everybody have a good weekend. I'll probably see you next week, possibly, somewhere. Hope you had fun.